we're going to talk about is the equipment that goes into a science room to keep it safe for everybody as well. So usually you start off, you have a control panel, and the control panel is the key heart of a safety room here. From the control panel, we'll be controlling utilities in that classroom, such as the electrical, gas, and water. Now, it's always a question, why do we have to control the utilities in a science room? Well, one of the main reasons is that there's been many cases throughout the country here where we've had explosions in science rooms where we just had basically a panic button, a gas valve, or nothing at all in there. As you can see here, there are some different areas throughout the country: Hawaii, Henderson, Tennessee, Yale universities, and they either happen during the day or late at night or on the weekends. And they can cause significant dollar value damages to the schools, which the school has to come up and pay for. Not only is the gas a big issue, but water. Water is probably one of the major ones because no one ever controls that. And some of the areas where we've seen damages done is from the emergency shower being pulled, and no one knows about it for maybe hours or days before if it's done over the weekend, and no one knows. Here are some other areas where it's caused millions of dollars damages versus what the gas has done. Water vandalism can be done not just with the emergency shower, but actually with the faucets at the student's desk. We've had cases where a student had taken a hose off the faucet, tied it into the gas valve, the gas jet, and over a long weekend completely filled the gas piping up with water all the way back to the main. So that was a very expensive deal for the school to deal with. When we got a call for it, they were $200,000 into it, and they weren't even quite done yet. So by controlling the water, keeping it off, that would have prevented any type of damage done to the piping system. Of course, then you always have that possibility of both fire and gas water going off, and that's even a worse combination there. There's just some areas here where we've had damages, and you see they're not cheap when you go in there and try to repair. A lot of times the instance will happen on a second or third floor where the science rooms are at, and it's not contained there. It actually goes throughout the whole building, especially with the water. We've had some electrical issues caused why we want to do that. Well, if you have gas in the classroom, if you get a spark from an electrical outlet for some reason, if it shorts out, now you got the explosion portion there. So it's a combination of trying to control all of these in a safe manner, and again, this is just protecting the building as well as if this has happened during the day, the school students and teachers involved. So what we like to present here is a system to where the utilities will be operated when they are needed. If the electricity doesn't need to be on at the student's desk, then we don't provide electricity to the student's desk. If the gas doesn't need to be on, we don't provide gas out either. So the teacher who is, or the instructor has authority so that they determine which utilities they want to have on at a certain time. Once these are active, then the students can operate and use them, but usually they will be under a supervision of the instructor. One thing is that if the teacher gets into a situation, we have emergency stops that we shut the system down completely, electric, gas, and water. And that's pretty much a nice little requirement there, or a feature, that you have these stop buttons. Of course, they can actually shut the utilities off with the rocker switch as well. The other issue we get into is that a lot of times you get a long weekend coming up. Teachers are pretty well in their zone for the weekend. They may leave and keep the utilities on. Well, this is when most vandalism actually occurs over a weekend. Students get back into the school. They know that the gas and water is on, and now they can do what they want to do. So we provide an auto shutdown with a system or the building management, energy management system. They can actually send a signal to enable and disable the control panel so that the control panel is inoperable. Even if a student were to get a key to start the system up, as long as it's disabled by the building management system, the system will not operate. So we recommend that, it's tied into the building management system so that at the end of the day, it's shut off, and then we know that that classroom is safe again. We just talked about automation there. Now, a lot of times you need to also control the fan, an exhaust fan in a classroom. And in a classroom, you have purge fans that will come on when an experiment is gone awry, where you got a chemical spill and you're trying to get it out of the room. The panic button will enable a exhaust fan to come on and purge any chemicals or anything in that classroom at that time out. The exhaust fan is controlled by a switch or by the panic button, but if an alarm signal is received, then the purge fan is not active because we don't want to introduce more air into a fire area. So alarm will disable, panic button will enable. And the other thing that you should be noticing is that we can tie into the fire alarm panel itself. The fire alarm panel will send a signal out, and that will disable the unit as well, so that we have complete shutdown during a fire situation. As long as that signal is maintained, you want to make sure that the system cannot be reset. So you be careful how you set up your fire alarm signals there. In a typical classroom, we're just kind of showing you where you'd want to have your equipment located and which equipments that you will have inside a room. Of course, the control panel, you want to locate it at your first egress to the outside. That has the panic button on there. If you have a second egress or a third egress, you want to just put remote panic buttons. That way, if any of the doors are blocked due to fire or something, you have other ways of shutting it down through remote panic buttons. Remote panic buttons can be either maintained or momentary, depending on what type of systems that you have. Usually momentary is enough just to break the signal to the control panel to shut everything down. You also have a fuel gas sensor. Fuel gas sensors are really good because if the room starts to fill up with gas, that will shut the system down and make sure that the unit cannot be reset. As long as that is sensing gas in that room, the unit will be shut down. The electrical and water also be shut down as well. The other thing, again, what we talked about is shower monitoring. So with a shower monitor, if someone were to pull the emergency shower, which is 20 gallons a minute, which can flood pretty quickly, then we can send a signal to the control panel, and from the control panel we can send a signal out to the fire alarm or the building administration through the controls of the energy management system to let them know that the shower is active. You do not want to have the flow sensor shut any of the water off. The water that goes to emergency shower is always before your system that's going to be designed to take care of the water in that classroom. It has to be free of any obstructions there. Then the other parts of the puzzle would be a solenoid enclosure. That's where the solenoids may be all housed in one area. Usually it's located in a prep room, or it can be in the classroom itself. But you want to have them in an enclosure where they're going to be easily accessible for the facilities people. If the facilities people can't get to it, then the solenoids will not be serviced, especially over a long period of time. Sometimes when they're located just above the ceiling, a lot of times the facilities people do not know where they're located, and sometimes they could be hard to get to because of ductwork, lighting, or other obstacles where the contractor may have installed them. So solenoids, they're going to need services over time, so why not locate them somewhere in an area where they can be easily accessible for the facilities people. Now the electrical panel, now that's a little bit, doesn't necessarily have to be in a classroom, but usually you want to locate it within the classroom, let's say above the ceiling, and the electrical panel is in between the main panel that you would design to and the receptacle. With an electrical panel, you want to be able to, you don't want to shunt that electrical panel off. You want to be able to control it with a mechanically held contactor that you can latch and unlatch as the day goes on. The other thing that might look good is a monitor beacon that goes outside the classroom. If you have a large school or a school that's spread out, when that panic button or alarm is hit, that will send that light will come on, and that just brings notification to that classroom so that someone can get to you quickly. They know exactly where it's at. So these are the components that we kind of recommend that's in a classroom to make it safe for everybody. Now you can then go into have the instructor's desk have their own control panel with its own valves and electrical panel as well, so that when the teacher wants to just do a demonstration at her desk, you can keep the students' gas, water, and electric off during her presentation or their presentation. The other room is the prep room. The prep room sometimes has its own facilities in there as well, and you want to have its own control panel with its water and gas and electric. One thing that you don't want to do is to have one control panel to control multiple rooms. One reason is, and it's a safety issue, is that what happens if those other rooms are not occupied? And the room that the instructor wants to have the gas on activates that, but the other rooms may have gas that are open, and now it starts filling up with gas and no one knows about it till maybe hours later on there. So each classroom and prep room would have its own system so that you know when that system is operated and what's actually operated from that system. So that's something to keep in mind when you're designing your systems. So now we're going to kind of explain basic systems and how it's going to how it functions. And one is you have your control panel. Let's go back here. And so what you do is you turn your rocker switch on. You have your service key that will activate the, sorry about that. You'll activate with the service key. That's what the teachers will have, and then it will energize your solenoids. When you, sorry about that. Now, once it's activated, the system will stay on as long as the rocker switch is on. Once you turn the rocker switch off or hit the panic button, then the system will shut off. Now, your solenoids can be 120 or 24 volts. Usually a good system will provide the power from the control panel to the utilities, like the solenoids, so that you don't have to have multiple electrical going to the solenoids or to the control panel. So the control panel sends all the power out to whatever they're trying to operate. A lot of the solenoids should be pre-assembled. The worst thing you do is to have a contractor try to assemble the system out in the field. If it's pre-assembled there from the manufacturer, then you know that the system has been tested and it's ready to go. It also makes it easier for the contractor just to bring his piping to and from the solenoid enclosure itself. Now, also located in a solenoid enclosure, you'd have your contacts that would already be factory made so that you can send from the control panel directly to the solenoid enclosure to operate the gas, water, and electric. Of course, when you have a control panel, you're not just limited to gas and water. You can control your compressed air, if you have exotic gases like in welding shops, you want to control those as well. So the solenoid enclosure basically houses whatever type of gas or air that you want to be able to control in the space itself. Now, turning on the electrical, it's basically the same thing. You turn your rocker switch to the on position, then you will turn the key. Once you turn the key, then it'll activate the electrical panel, and now you have your electrical going to the student's desk. Now, in today's technology, teachers now are relying on more using computers, and so there's certain areas that in a classroom that you want to have the electric on all the time. And you don't want to have the students on all the time, so what you can do is you can actually set up another set of contacts within the same enclosure, and that would power the teacher's desk, her computers, any type of visual aids. Let's say you have an aquarium or refrigerators that need to be on all the time, and that set of contacts would actually be controlled through the panic button. So as long as the system is operational, those outlets would stay on all the time, but when you hit the panic button or an alarm signal comes in, it shuts all the electricity off in that classroom. This way the teachers has their system on all the time, then they control the students' electrical to make sure that they're off when they don't need to be on if they're not using it. So when you're doing an electrical classroom, just be cognizant of what units need to be left on all the time, except for emergency, and what can be controlled. Mechanically held contactors are really good, like Square D or Eaton, because you can latch and unlatch those contactors without having to call the facilities people and reset it through a shunt trip. Again, you want to have a manufacturer that's going to pre-assemble all this for you, so you don't have to have your contractors in the field try to assemble it, try to figure out how they're going to run the power to it, and how to control it. In a nice, easy package like you see here, we use relays to open and close the contactors in that workstation there. Again, if you have your teachers tied to their own system, they would have their own relay and their own set of contacts within that same enclosure there. Now, we're going to talk just about basically how to turn the system on and off on this system here. So you got your control panel, you're on, you got electric on, you got your gas and water on, and now it's time to be in the class, and you're going to go to shutting the system down. So all you need to do is just take this rocker switch, turn it in the off position, and then it opens up the contact, shuts the power off to the student's desk. Next, you do the same thing with your water and your gas. You touch those switches off, sends a signal over to the solenoids, and then they will then turn off when you shut those buttons off. So the panic button is not required to shut the system down. We don't recommend they use the panic button only in an emergency situation, especially if you're tied into the fire alarm panel and you don't want to send a false signal to the fire alarm panel. When we send a signal to the fire alarm panel, we do not activate, you don't want to activate the fire alarm panel. All you're doing is sending a supervisory signal to it, letting someone know that something's going on in that room. So just turn your rocker switches off. You do not have to have the key to turn the system off either. You just shut the power off. Now, once the power is shut off to the utilities, a student cannot, just by simply going up and turning the rocker switch back on, think that they'll be able to activate the system. It will not activate unless you have that service key to initialize the system. So every time you turn the utilities back on, you do have to initialize the system for those utilities to be turned on. That's why we give a key to the teacher only, so they determine when they want to have their utilities on. Now, when you hit strike the panic button, of course, if you're in a situation, then they will they'll automatically shut the system down. It sends the light beacon will turn on so that they know where to directly go to, so they're not hunting from room to room on there. And once the problem, the issue is taken care of, then you can just rekey the service switch, utilities come back on. And then the light panels. Now, as you notice on the presentation here, you saw the green lights and the red light come on at the same time. That is when the panic button or alarm signal is activated. Those will come on just to let you know that you were in an emergency situation there. And once you rekey it, the services come back on, the red lights go out. You know, we're talking about building automation, and some of these units have their own built-in automation system to shut down after a certain period of time. This is, when you're tying them into the building management system, they can enable that box to come on at a certain time period, let's say 8 o'clock in the morning and 6 o'clock at night, sends a signal to disable it. Once the building automation system disables it, the unit cannot be restarted until that time period is reset again and allows an enabling of that unit. You can turn the key all you want, turn the switches on and off. Nothing will happen until that is done. Some of these units have what they call a first-time keying that's built into the system already. Now, the first-time keying, what that does is sets up a time clock for a period of time, let's just say 8 hours. When that key isn't turned off for the first time, it sets the time clock up, and the teachers then can turn on the utilities on and off as many times as they need to during the day without restarting that time clock again. This is just another way of making sure that over a long weekend or even just during the week that the utilities are shut off, and if a student were to get into it and try to, let's say, flood the classroom, at least after a certain period of time would shut all the water off and the gas and electric so that very minimal damage, if any, would be performed. This is just showing that it's been disabled. The lights come on, let you know that the system is down. Same thing with the fire alarm. You get a fire alarm signal coming in, and we do recommend that that is part of the system so that when it is sent, it deactivates the system and all utilities shut off during that alarm situation. That's very critical because you don't want to have a gas on or any electrical on when there's water and fire coming on into the building. So as long as that signal, fire alarm signal, is active, no one can reset the system. So the fire alarm sends a maintained signal at all times, and that will keep the system from operating again. Once that signal is withdrawn, when the situation is under control and everything's back to normal, then you can actually re-engage the system so that it does come back on again. Now the fan. Purge fan is used so that if you have a experiment and you're creating some odors that you don't want, or you have a slight chemical spill that has gas that's floating in the air and you want to be able to exhaust that out, there's a switch on the control panel that can be turned on and off without activating the key. That's the key thing. The fan needs to come on when they need it. Also, again, the fan will come on when you hit the panic button. Now, the fan can be programmed to normal operation where you're just turning it on just because you want to evacuate the stink that you might be experiment that you're doing, or you can have a high-low fan situation to where when a panic button is hit, you want to withdraw all that chemical out there quickly so you can actually have it on a high-speed fan to boost that fan up and off. Now, once if you hit the panic button and you are in your high-speed fan, the only way to shut that off is to reset the system with the key, and then that will set it to normal operation again. As long as the panic button has activated the fan, your switch is not operable, because we want to make sure that the only way that fan shuts back off is when you reset the system, because then again your emergency is over on there. This is just showing how you just turn the switch on and off. And this is an alarm input to deactivate the fan. As we spoke before, we do not want the fan to run if there's a fire inside the building, because we know that more oxygen fuels the fire. So an alarm signal coming in will not let the purge fan come on. It only comes on in a panic situation, not an alarm. Now, other features that we were talking about is your flow sensor. Again, the flow sensor just monitors the flow coming out of your emergency shower eye wash. And on we're not stopping the flow. We're not trying to keep it from operating. For one thing, it's against code to do that. All we want to do is send a signal out through the control panel to a supervisory signal back on the fire alarm, or to a monitor panel located in the principal's office or some administration area to let you know that, hey, something's going on in this room, we need to get down there right away. And when they see the water flowing, of course, they'll be able to shut the system down by pushing the arms back up or shutting off the eye wash valve itself. Emergency stop buttons is always a good idea to have more than just, say, one. Usually in most systems you can hook up additionals as up to 5 or 6 different panic buttons to one system. And at least you should do is the egress is out of the classroom. That should be definitely areas where you have panic buttons by. But locating by the teacher's desk, that way she doesn't have to run across the room and hit the panic button. If she needs it right there by her desk, that's another good location to locate that at. We talked about the monitoring beacon. All that does is, especially in large schools or schools are spread out, it lets you know exactly where that panic situation or that need to have some assistance being drawn to quickly. All they got to do is look for the emergency light going on, and they can go directly to that space and assist to whatever's happening. We're finding that the using the panic button is not necessarily used for the utilities. We're finding that in some instances that the panic button, along with this monitoring beacon, is used to help with if you have really children that don't want to listen to the teachers and they're having difficulties with them. It's a good way of sending a signal to get help to them if they have an unruly student in there. And of course, the best way to protect your building is to have a fuel gas sensor. Fuel gas sensor monitors 24/7, 365 days a year. It does not shut off. That's constantly on so that if a gas turret is left open, or let's say you get a gas pipe that leaks, at least in the classroom itself, it will sense that gas in there and then shut the system down. The fuel gas sensor will send a signal out to a supervisory signal to the administrators, but as long as that sensor is sensing gas, the system cannot be reactivated until the area is cleared and the sensor no longer senses fuel in the area. So these are items that a lot of times are overlooked or no one's said, well, it's not quite in the budget, but these are minimal safety devices that will help keep your control panel that you're using operational 24/7. Again, just to kind of reiterate what we're trying to do here, the administrative level would be like the principal, the building owners, they would be the maintenance facilities. Those guys would be to make sure the system's operating correctly. They would also have control whether they want the system on or off. Those would be your first tier. Your second tier would be your instructors at the classroom level. Those will be, all they need is to be able to turn the system on and off as they need it per their class, whatever they're doing that day. And then your end users, of course, will be the students that will be able to utilize the system also to help in emergency situations shut the system down. So that's kind of the pyramid of how this system really operates and why we're doing it. Again, is to protect the building, to protect the students. And you may find that we're seeing some places in the country that insurance companies are requiring systems like this to help protect their buildings and also helps the insurance costs of the building if they have this. So it's a system that shouldn't be overlooked and shouldn't be valued and engineered out too critically. As you see, this will help protect the building. Even though your main local codes only require the use of controlling gas, as an engineer, it's also kind of your responsibility to make sure the building is safe too through other ventures like water and electrical hazards that can happen. So it's kind of a good idea to let the schools know about it and to inform them what you can do to protect their facility as well. And of course, these systems aren't just localized to the classroom. You've got the science room, or you have home ec, you have gas and electric stoves in there that should be monitored as well. You have shop areas, the shop areas where you have bandsaws, weldings, areas there, which is more critical than what a science lab is, to where you want to control those high-pressed equipment that can damage the students, cut fingers off or stuff like that. And the other areas are mechanical rooms, too. Mechanical rooms need to have some type of safety device in there so they can shut down and operate just for maintenance and for tying into the building management or fire alarm system, make sure that they shut down during a fire alarm situation. So really, you're not just restricted just to the classroom itself, but you may want to look at the complete building as trying to protect that as one on there. So, you know, innovative systems, integrated mechanical and electrical technologies is what you're developing here, and it's going to promote safety for instructors, students, and the building itself. So just kind of recap on what we kind of discussed here. We're controlling electric, gas, water, fan. You have to have a key to activate the system, and it can only be done by an authorized person, so accidental vandalism doesn't occur. Panic buttons, make sure you have enough of those around there so the system can be turned off. And also activate exhaust fans for experiments that may require some extra exhaust just to get rid of the fumes. Of course, during a fire alarm situation, you don't want to have that fan on. Automatically turn utilities off through building automation or an integrated timer. That's always good to have in there. Plus, you know, we are code compliance. You're actually going above and beyond the codes for that area of your school district that you're working with to help them have these expensive costs when vandalism occurs. Again, gas sensors just to make sure that if there is a leak of any type, that it shuts the system down. Monitor beacons just to notify where that panic or situation where you need help in. It's a lot quicker to look for one of those, especially when you have multiple science rooms. You don't know which one, you're trying to go to each one. This lets you know which one automatically. Monitoring the shower flows. Students love to turn on those showers and let that run. And again, just to keep a safer environment to all the facility itself for students, the building, and all that. You want to make sure that whatever equipment you do use is a UL listed package. You know, it also complies with some of the other codes, the NFPA, International Fuel Code. So that's what these systems can do and can provide you to meet all the national codes that are around there. This is just simply kind of everything what we've talked about, what you'd want to have in your classroom. Of course, your control panel. And then you determine if you want a 3-switch or a 4-switch. You have your panic buttons on there. Then you have your solenoid enclosures. They can be flush mounted or they can be surface mounted with your gas, water, or whatever other air or other gases you want to control within that classroom. Your electrical enclosures, again, those can be flush mounted or surface mounted, and that's just control the student circuits in that area. And then just what we talked about, the additional features. So this will be something that you would actually engineer into a classroom or into your building to control certain areas. Again, one thing you want to do is to, wherever you're at, since they are isolated areas by rooms, that you have your own control panel with its own set of utilities, solenoids, electrical outlets, and their own monitoring systems. Again, you don't want to have to turn a system on and worry about other areas that may be connected to it that could fill up with gas or turn water on and you don't know water is running and start flooding out the classrooms on there. So Isimet, we've been around for almost 20 years here, and we've been doing this for quite a long time. And we can customize pretty much anything that you guys want to put out there. We do have some basic packages that includes everything that we were talking about, so it makes it easier for you to help design it. But we also have the local reps in that area that are well knowledgeable of the systems that can also help you decide what you need with model numbers and stuff like that. So, Jim, I'm going to turn this back over to you and to open it up to the floor to see if there's any questions.
Yeah, thanks, Pierre. That was a great presentation. We do have a couple questions. Read some off to you here. The first is, can the fan button be programmed to come on and off automatically when the gas is turned on or off? Maybe paired with it, I guess.
We want that to be controlled separately. We don't have it as a timer. I mean, that's why we have the switch there, so that when the gas is on, the teacher just has to turn the switch to the fan on. But as trying to tie it into just the gas switch, no, at this time here, we don't do something like that.
Okay. Next question. For the fuel gas sensor, do they shut down the gas automatically when it detects gas, or is it just like an alarm for someone to turn it off?
No, it automatically shuts the system down. In fact, it shuts the whole control panel down. So your electric and your water as well as the gas will be shut off.
Great, okay. Okay, one more question. Can a panic button be wired to turn a safety shower on? If so, will this conflict with ANSI standards?
No, you cannot have a panic button, because basically what you're saying is you want to have a solenoid in line for that safety shower, and if you do that, that would not meet ANSI's system. The ANSI system for showers, you cannot have any type of restriction that can cause that water to stop at any time. So we actually had a situation like this in another state where the school district wanted us to control that, and understanding why is because, they don't want anybody to pull those down. But with solenoids, you're going to have to power that open at all time. And when you power it open, you have the possibility of that being shut. And when you do need to use that, you won't be able to open up that solenoid, because what happens is the solenoid can collect minerals, deposits left behind when the water evaporates out of the solenoid armature where the coil sits, and now you have buildup, and it keeps it from opening. Even though you have a fail-safe opening, you're powering it closed all the time, and when it comes to use it, you won't have any water. So no, you cannot have a panic button to control the water on a safety shower.
Okay. Well, thanks again, Pierre. It was a great presentation, and thanks again for all the engineers who joined us today, and for your continued support of Disney-McLane University. Later on today, you'll find a recording of this class on our YouTube channel. If you have trouble finding it, it's also on our website, a link to our YouTube channel, just in case you ever want to watch this again later. Be sure to join us for our next class, which is going to be on October 9th. It's a hands-on class hosted here at Disney-McLane headquarters. It's going to be over drainage solutions, a hands-on drainage solutions class. But yeah, thanks again, Pierre.
Thank you.
Until next time. Talk to you guys later. See ya.
Okay, thanks a lot, Jim.
Thanks, Pierre.